Students, we are finally in our last lesson for Unit 2. And in this lesson, we're going to culminate this idea of solving equations for not solving for an answer necessarily, maybe some other variables. And so I guess to start with, let's just recall what we already know how to do quite easily. And here's an example of a two-step equation. And so again, my goal here is to solve for x, to get x by itself. And so I'm going to do that reverse order of operations thing. I'm going to 12 from both sides, 5x equal. And instead of actually making it 20 right now, I'm just going to leave it as it is. 32 minus 12. This is for a purpose to make a connection to what we'll be doing later on today. And here, in order to get x by itself, I would divide both sides by 5. And so, again, if I just left it out, I would have x equals 32 minus 12 divided by 5. And so here, you can see that I'm not to solve and get just one particular number. I've got it all kind of in a messy version here, and that's essentially how it's going to look when I rewrite equations. So an example of something that you might see would be here in example 2. And so if I start out with ax plus b equals c, obviously I'm not going to get a number answer when I'm done, but I can to x by itself. So if I want to solve for x, I'm going to subtract b from both sides. And of course b minus b is 0, so I'm left with a times x. On the right hand side, c and b are not like terms, so I can't combine them. I just have to leave it c. And then for my final step, I have a times x, and I want to get x by itself, so I'm going to divide both sides. Now a divided by a is 1, and 1 times x is x, so that's 12 for x. But on the right hand side, I have a nice clean number like I usually do. I just have c minus divided by a, and that's going to have to be good enough for now. So this strategy is turning what standard form into slope when we start graphing things soon. This is one of the skills that you'll have to. So again, if I want to solve for y, it means I want to get rid of everything besides y on one side. Okay, so I have this negative 2x here, and I want to put the whole negative 2x on the other side. I want to get rid of it. And so what I'm going to do is I'm going to add 2x to the left. Negative 2x plus 2x is 0. 0 plus 3y is just 3y. Okay, so I'm getting closer to just getting y by itself. And of course, when I add 2x to the right-hand side of the equation, 6 and 2x, those aren't like terms either. I can't combine them, and so I have to leave it 6 plus 2x. And I'm actually going to write it 2x plus 6. We usually do the variable before a regular number or a constant. My final thing, the opposite of multiplication, is division, so I divide both sides by 3. And on the left, 3 divided by 3 is 1. 1 times y is just y. I have accomplished my mission. I've got y all by itself. Now, we need to remember that not only do I need to divide this 2x by 3, I also have 6 by 3. So 2x divided by 3, well, that's just going to wind up being 2/3 x, or 2x divided by 3. But then don't forget, you need to divide this 6 by 3 as well, and that turns out to be a little neater. 6 divided by 3 is 2. And so I have solved for y. I've gotten y by itself. And again, it's not a nice clean answer, y equals 7, but it is solved for y. All right, that's it. We're done with Unit 2.